Hi, everybody. I don't have a rap, sorry. I'm not very good at rapping, but this summer, I had the opportunity to focus on Atlantic croaker, doing the age and growth dynamics of Atlantic croaker in the sound, Micropogonias undulatus. That's this fish here. So the species they gave me was, like I said, Micropogonias undulatus. It's part of the drum family, like red drum and black drum, and they're characteristic for the drumming noise they make during mating season. That's what they do. They have a benthic diet of worms, crustaceans, small fishes, and shrimp, and they're normally found in Atlantic commercial fisheries. So actually, I was given this fish because they're understudied in like terms of age and growth dynamics. So that's what I had the privilege of doing. So the species range is actually rather broad. They can range all the way from Massachusetts Bay, which is up past the range, and then all the way down to Campeche Bay, Mexico. Now, normally the adults stay inshore, but they go outshore when it's respawning season. So in the past, populations used to achieve a much larger size. So if you look in the picture here, that this lady's holding, so she's actually holding a 15-inch croaker right here. And max size in past literature was 419 millimeters, which is 16.5 inches. But nowadays, only get to be about this size, the palm of your hand, which is rather small for a fish. And that led to my big question: what is the age and growth of Atlantic croaker in Mississippi Sound? So the fish from my project were collected for doing monthly sampling using a gill net from the years of 2005 to 2015. They went to these following sites on the map. They used a monofilament gill net and they used a 1 hour fish time, which just means that like they set the net out for an hour and then left it there and then came back another fish later out. So to remove the otoliths, the fish were brought back to the lab and we weighed them, measured them, and sexed them. And then after that, I removed the otoliths from the fish. So the sagittal otoliths, which is the big one right here, were removed from the fish. Now, in most bony fishes, they actually have 6 otoliths, 3 on each side. But the sagittal otoliths in the picture, those are the biggest ones. So we use those for aging. You might be wondering, Karrington, what is an otolith? And I'm really glad you guys asked me that. So an otolith is actually it's the same thing that we have in order to like the balance when we stand up and you don't fall over or have vertigo. Fish have the exact same thing. That's what the otolith is. Now, otoliths are made of calcium carbonate, and they're used for both balance and hearing, and they float in the fluid sac in the fish's skull, which you can see right there. That's below the brain. Now, most bony fish, the size of the otolith actually varies from fish to fish depending on where they live. So the croaker here, they live in the sound, and I don't know if you guys have seen it, but it's really brown and kind of dirty looking. You can't actually like see the water in there if you were to like put your head down. So they have larger otoliths because they need to use like their spatial awareness to get around. As compared to like a billfish, giant marlin, they have really, really like tiny otoliths because they have huge eyeballs because the open ocean is like really clear. You can see. Now, once I took the otoliths out, I had to place them in epoxy resin molds, and once they're in the mold, I had to place the line over the sulcus so I could actually make the cut. So the otoliths were cut the nucleus, this part right here, with a diamond wafering blade and a low-speed saw. And then a second cut was made, a parallel cut was made to obtain a 400 micrometer cross section. I use this saw right here. So the otoliths were viewed by 2 independent readers, me and somebody else with a dissecting microscope. We used both transmitted and reflected light. So reader precision and agreement were determined, and the annuli were counted. Before you ask me, this is the annuli. So you see this dark line right here, this opaque line? You guys see it? Okay. That's the winter growth, right? So they pack this on in the winter months when the food is there's not that much food. And then the translucent line right here, this thicker broad line, they pack that on during the summer months where food is more abundant. So after I counted the annuli, the 4 lines, I then determined the margin code. So the margin code is what you see here above the last dark line. You apply a margin code to that to see how far they're into the next year. Now, these equations look confusing, and they are, but lucky I know what they mean. So, so I took the year data and I applied it to these 3 growth models to see which one fit best. So we have the 3-parameter von Bertalanffy. This is a standard model they use for fish age and growth. That's like what everybody uses. Then we have the Gompertz. So this is a model we actually use in animal science. It was made for mammals. It's for species with determining growth, so we had to see if that worked too. And then we have the logistic model down here. That's actually a basic statistical model that we use on things with asymptotic growth curves. Now for my results. So I analyzed 560 fish, 365 females, 81 males, and 114 unknown fish. And unknown fish are just fish that couldn't be sexed, either because they were too young or when we got them, they weren't in their spawning season. Okay, so on the x-axis here, we have the total length, and on the y, we have the weight. So as we can see with this graph, as the fish get longer, they put on more weight as they grow up, just like we all do. So breeder precision was then determined, like I said before. We use a age bias plot. That's this right here. So we both age 50 slides separately, and then we have the mean age on the x and the age difference between me, reader 1, and reader 2 on the y. As you guys can see, it's a straight line because we all aged exactly the same. Yes, it's so great. But Croaker are actually really easy to age, as you guys saw. So our average percent error was 0%, because there was no difference. Now, back to these results. So this plot here, we have age on the x and then total length on the y. So for the range for the females was 1.25 years old to 9.25 years old. This one all the way in the corner. Then for males, they ranged from ages 1.25 to 4.75 years old. And for the unknowns, they ranged from 1.25 to 4.25 years old. Now, back to this graph here. As we can see, at the age of 2, you can be any size you want. And it's the same for... So it's showing here that total length actually does not relate to age really much at all. If we look at this outlier right here, remember that she's an outlier, 9.25 years old, she's actually smaller than a lot of the fish that are younger than her. That's just her, I guess. So. Now, these are the growth models by sex. So on the x-axis here, we have the age, and on the y, we have the length. Before you get confused, this graph is actually really simple. The red dots here represent the female fish, and then the blue dots represent the male. And these 2 lines right here is actually 6 lines, believe it or not. And those are different growth models that are all put together. But as we can see, that looks like one giant line. And that's because if we look at these R-squared values over here, they're all about the same number, which is why they're so close together. But the way R-squared values work is they go from 0.1 to 0.999. As we can see, mine are really low. And that's not a good thing. It's because the graphs actually don't fit the data that well. But that's not actually a problem, though. Because again, like I said, the age and the total length don't really relate. So this table here compares this study to 2 studies done in the past, Barger in 1985 and White and Chittenden in 1977. So as we can see, the max length age that I had for my fish was 320 millimeters. And then in Barger, he had 417 millimeters, and White and Chittenden had 357. Now, as we can see, my fish is the smallest one here. And then for max age, my Jane Doe, the outlier, she's 9.25 years old, but Barger had an 8-year-old fish, and then White and Chittenden had a 2-year-old fish. That was her max age. But let's remember here, I have the oldest fish, yet the smallest, and they have younger fish than I do, yet they're both bigger than mine. Why is that? We'll get there. So this is a growth comparison chart between this study, 2025, and Barger's study in 1985. So on the x-axis here, we have age, and on the y, we have the length. So the red line is this study, and the blue line is Barger's study in the past. So as we can see, on average, Barger's fish are all older than mine. And this is actually something that we're seeing happen globally because fish are shrinking. So in conclusion, females generally achieve a larger size than the males. Size does not relate well to age as we saw, and in previous literature, the maximum age observed was 8, and our max was 9.25. But remember, she was an outlier. That's important. So for future directions, I'd like to compare scale and otolith aging methods to take this study further, because in previous literature, they use scales to age their fish, but in present time, we use otoliths because scales is like kind of incorrect. Because for a fish can shed its scales anytime it wants and then grow them back. So it might not be that accurate. But to understand previous literature, we have to know what they did and know how that works. And then I want to increase the spatial scope of sampling. So I want both a larger age sample and to increase the scale like geographically. So instead of doing the sound, I'd rather do the entire Gulf of America, sorry. And then I'd like to look at other croaker species to compare age and growth and what makes them different. So believe it or not, there's actually another croaker species all the way in, their range is from like below the Amazon River to Argentina. They're called Micropogonias funieri. And I want to see what their age and growth is. You know, are they any bigger? Are they any older? You know. I want to say thank you to this whole internship program for, you know, bringing me here and paying. I want to say thank you for the croaker sampling because they paid too, so I get those fish. And I want to thank the entire GCRL lab, so that's Jill and Lillian and Tiffany and Jeremy. And I want to thank the other interns too. So that's Calvin right there. There's Lindsay, there's Morgan, and there's Kirsten too. I want to thank them. Now, before I get to the questions, the first month and a half of my internship, I actually did not do my project. But I wouldn't have it any other way. I really prefer it that way. So this picture right here is me holding this red snapper. We ate it on CMAP. It was, yeah, I liked it. It was pretty good. Yeah, it was pretty good. And this here is me and Lillian. She's right there in the corner. This is us on the sorting table. This is me bringing in this giant trough full of pinfish. I thought it was really trifling, but we did it. And then this is this crab I caught. His name is Krabby Patty. He's a Calapafilia crab, but I freed him because that was a nice thing to do. And then this is me on long line with the shark class. This is me with an Atlantic sharp nose. This is the same picture that's in the program. I put it there. And this is the actual shark class where we went seining. This is like one of the first days I was here. But now for the real questions. I really tried.
Yeah. I have two questions.
Yep.
The first one is, are croaker shrinking? You said croaker are shrinking. Are they really shrinking? What does that mean?
So I would say that croaker are shrinking. Well, but if I'm going to be honest, our study is only in the sound, so like I can't say like definitively yes, they're all shrinking, because again, like I said, the range for croaker is from Massachusetts Bay all the way to the Gulf of Mexico. So I can't just say definitively for the whole, you know, range that they are actually shrinking. But I will say for the ones down here in the sound, they are rather small.
So they're just not getting as big as they used to. They're not physically like.
No, they're not physically shrinking like that. But I will say, I'm going to put it this way. So if you guys were to go hunting, do you want the smallest doe or do you want the biggest one? This is a real question. Okay, you want the biggest one, right? Now you can apply that same analogy to fish. You want the biggest fish, right? Exactly. So again, if we all think that and we all get the biggest fish, that causes the rest of those small fish left behind to start to naturally select to where they only get so big because they don't want to be caught by us.
My second question, Karrington,
Mm-hmm.
is how did you remove the otoliths?
I'm so glad you asked. So glad you asked me that. Purely because that was one of my favorite parts of this whole project. It was so fun. I'm gonna go back to the picture. So if we look at this fish right here, right? You're gonna take the croaker and you're gonna make a cut right in front of the dorsal fin, like on the forehead of the fish, kind of. And then you're gonna make a cut and you're gonna fold it back. Now you know you've done it right if you can see the brain. Normally the brain's right there, but I took it out. If you can see the brain right there, you know you've done it right. Now since the brain is in the way, you have to like swirl it out with your tweezers and then put some water to wash it out. And then you'll see the otoliths right in that little crevice. Can y'all see them? They're like two little white shields, kind of. Yeah, it's really cool. Because when you actually, for most fish, you can't really see them unless you know what you're looking for, but you know you've hit them if you can like hear a little scraping noise. Yes.
Brain swirler.
Yes. I did a lot of brain swirling. Any more questions?
You killed it. Nice job.
Thank you. Yes.
Hey there, nice job.
Hi, Jesse. Thank you.
So is it unusual to have a 0% error rate between readers of the otolith age?
Yes, it is. Yes, it is.
I thought
Because
so too.
yeah, you're right. It is. Other fish, they have like greater amberjack. Their otoliths are really hard to read. Now, I'm not gonna lie. When I first started reading them, I don't know if you guys noticed this, but can you actually see a little ring right there? No, you can't, right? You can't really see it right here either, can you? No, you can't. And you know, when I first started aging them, I couldn't either. So I actually aged the first like 200 of them incorrectly because I was like, this is because they call it the smudge. This is like their first year because they croakers spawn in the winter. It's cold, less food. So they have this giant black ring. But the other reader had to tell me, hey, there's actually a ring right there. Like that actually does count. So yeah, there's 4 right there. But after I had that right, we all aged correctly. Like after that, it's pretty simple. You just count 1, 2, 3, 4. Yeah.
She's just that good.
That's what they say. That's what they say. Yeah.
Great job.
Thank you.
So you mentioned that you thought fishing pressure perhaps had an influence on the growth. Are there any other factors that you think may be contributing to this smaller overall size within the sound?
So I'm not gonna take a guess, but what I was thinking is that number one, we fish for fish because we like to eat fish, but other fish also like to eat fish, and they like big fish too because everyone likes to be full, right? Everybody has to eat. Yeah, so there's that, and then other things like I don't know if you guys have noticed, but the other projects up here have been about oysters, and if you guys noticed, they're like, oh, you know, the oysters, we're trying to make them come back and things like that. So I would say food as well, like food might be becoming more scarce for the other fish. So like maybe they have to compete a lot harder to get to the fish they need to live and survive. So,
Awesome. Thank you.
Anybody else? Okay.
Good job.